We're live. My guest today is Bo Du. He's co-founder at Polymer Labs. Polymer is advancing Web3 interoperability by building a universal and modular IBC router that expands the IBC network. Super exciting. In today's conversation, we'll discuss why it's hard to expand IBC outside of Cosmos SDK chains, and we'll also dive deep into IBC and how it works. We'll talk about optimistic IBC, ZK IBC, their new ZK-friendly tenement consensus engine. I guess it's not that new. They released it they announced it a couple months ago, and integrating Polymer with the modular stack. I'm also dying to find out why he thinks other interoperability solutions are not protocols. Before we get started, make sure to hit the like button, hit the notification bell, and subscribe to get notified when I go live every week. And remember that what we discuss here on the Interop is investment advice. And if you like what we're doing on this channel, please consider staking with us. We're validating on the FMOS, Quicksilver, Osmosis, and Juno. Just look for Interop in the active set. And I hope you've booked your flights to Paris for the summer. Bo, I know you have, because Nebula Summit is happening on July 24th and 25th. It's a 2-day conference with technical talks about Cosmos, IBC, the interchain, no panels, no suits, just tech talks and a lot of fun. Tickets are still on sale, and you can get those at nebular.builders. And if you're coming to Nebula Summit, you should also register for Nebular Hack Day. That's happening on the 23rd. It'll be technical workshops. You can find all the details on the website. My guest, Bo Du, is coming up next, right here on the Interop. Hi, Bo. How's it going?
Not bad. How about yourself?
Great. Thanks for joining me here on the Interop. I've been wanting to get you guys on the show for a long time, and Peter was always like, "Yeah, it's not the right time. It's not the right time." But I'm glad today is the right time because, Polymer is super cool. And I'm sure you know this, but so many teams that I talk to tell me that they're integrating with Polymer and they're looking forward to Polymer, and Polymer is going to solve so many problems. And so I wanted to get you on the show to talk about IBC, hopefully getting a better understanding of IBC. We've talked about IBC on this channel so many times, but just getting a deep technical understanding of it, how it works, and why it's hard to integrate IBC with other chains that don't support Common BFT and so much more. So first, how did you get interested in interoperability as a problem that you wanted to work on?
I would say it started with my time working part-time in DeFi. So I spent some time moonlighting on the side on a number of Ethereum DeFi protocols. And this is kind of at the tail end of DeFi summer. You had an expansion to different chains like BSC and so on. And you had some of these early interoperability products like multi-chain / AnySwap. And there's also other existing solutions like decentralized custodians or somewhat decentralized custodians like Ren. And at the time we were trying to expand our protocols. Yeah, sure. We were actually collaborating with them somewhat in the early days. They actually had similar ideas to what Axolar is doing now. They had the Ren VM, Axolar's AVM, although it's not really Axolar's VM, it's Cosmosm. But Ren, had some of these plans and some of these ideas. And as I was building on the DeFi side, I was like, oh, maybe we can explore how we can expand cross-chain. And then through that expansion, it was kind of apparent to us, if you wanted to build something cross-chain, you had to build another blockchain, because there was no way to really seamlessly interop. There was no general interoperability solution across all these different ecosystems at that time, which makes sense because it was a heavily concentrated on Ethereum, a lot of the DeFi. And I slowly started expanding out. You have early projects like Thorchain try to tackle this. But then when we started to build, I guess, some of the early versions of what we wanted to do on the interoperability side, we kind of realized that the solution that we're building was very similar to IBC. So as we were trying to solve some of the questions of, if I have two smart contracts on two different chains, if I want to negotiate versioning across them, if I want to handle upgradability, if I want to have authenticated communication paths, as you go down the laundry list of features, you end up in a very similar place to IBC. So like through this building process and also through this like discovery process, we focused on, we should just build with IBC, figure out how to extend this protocol to all these different chains.
Very cool. Yeah, I mean, and very needed, because I think for a lot of folks in the Cosmos space that have been following, Cosmos since the beginning, IBC has always, at least for me, been this really impressive standard that we all hoped would spread to other chains outside of the interchain ecosystem. And it really feels like that's starting to happen. There are teams that, I mean, obviously you guys are a big part of that, helping that work happen. There are teams that are building IBC, connections to Avalanche, to Solana, to the Move ecosystem, to Near, etc. And it really feels like the IBC pill is spreading across the boundaries of Cosmos or the interchain. Is that something you're also seeing happening? Like when speaking with teams outside of Cosmos, do they have knowledge about IBC? Are they familiar with it? Are they bullish on it? Or are other interoperability solutions favored there?
Yeah, I see that a lot of folks that are very interested in IBC. Yeah, as you mentioned, there are a number of teams building with it and extending it to different ecosystems. But to play devil's advocate here, I also see there's a lot of folks that, it's difficult to integrate natively. So there's a lot of folks that maybe have tried to do it. Maybe they have like different opinions on like why we should have something simpler. I've seen the argument for like, oh, connections, channels, packets. That's it's too complicated. Like why don't we just have like a simple get posting? And I think what a lot of people miss is there's layers to the stack. And I think what's often missed is the concept of these layers and how they fit into each other. Since like if you think about the problem from like, let's make something super simple, like get post, or I'm just gonna send some bytes from one chain to the next. It limits what you can build, since essentially what you're describing is an application layer protocol and not a transport layer protocol. And I will get into that more through the rest of this podcast.
Yeah, no, and I think that's accurate. I think realizing that there's more than just sending bytes from one chain to the other. I mean, you have to take into account, of course, the transport layer, the sort of adversarial space that exists there, right, in the transport layer between different chains, and then the state layer. I mean, state needs to update between on two different state machines, and that needs to happen in lockstep. It needs to happen accurately, right? Like if assets are minted on one chain, well, they have to be destroyed on the other, and that has to happen in a certain sequence and with some degree of certainty. And so all these things taken into consideration make interoperability so difficult. I mean, that's why interoperability in crypto has been so difficult. So let's dive into IBC a little bit, and I'd like to maybe start by describing. Let's take a simple example. Let's take the example that a lot of people are probably familiar with, right? They listen to this podcast, is moving tokens from chain A to chain B. Let's take, Atom, like the Cosmos zone. We're moving Atom to Osmosis. When you open Kepler and you initiate an IBC transaction from Cosmos to Osmosis, what's happening behind the scenes? Like from the Atom zone to the Cosmos zone, how's that information being transferred, and how do you magically end up with like Atom on your Kepler wallet over on Osmosis?
So I'm going to gloss over some of the transport layer details and focus on what's happening at the application layer. Since token transfer, or ICS-20, is an application standard, it's an example of what can be built on the IBC transport standard. But I would say that like it's not, it can be built on any transport standard, but on the IBC transport in particular, you're able to kind of like agree on some semantics here. So for when someone transfers some tokens, they're essentially escrowing those original tokens. So it's not like the tokens get burned. So I think a lot of people have this misconception that these tokens are burned and then minted on some other chain. They're actually escrowed by what's known as like a module owned account. This is essentially controlled by the chain's consensus. since you have some chain that has some consensus, you're able to have like a chain-owned account. It's not owned by a private key. It's owned by a specific SDK module on that chain. When these tokens are then transferred over, you mint a essentially, you can think of it as a wrapped asset, because you're tracking the denomination. And what's in the denomination is you've taken the token identifier, which may be some, let's just say it's like token like Atom, and then you're adding the channel path, like channel ID. Let's say you transferred over like channel 0, so it would be channel 0, and that's what you get on the chain that you transfer to. This information is relative to source. So starting from the original chain, it matters which channel you've gone over, because all this channel information is only maps to chains based on the view from the source chain of all the additional chains. There's no like global identifier saying that you transferred this token to like Juno or Osmosis. There's no like global Osmosis or Juno identifier. It's all relative. So every single chain has a relative view of every other chain. I think this is a very difficult concept for most users to grasp. They just assume that there's probably like, oh, there's like this global like DNS thing where everyone like knows which chain your token is on.
Yeah, but so just to stop on that point for a second. So what you're saying is that chains know the identifiers of the chains that they're connected to, but beyond that, they don't. So for example, when moving Atom to Osmosis, we're using a channel. That channel has an identifier. Now, when moving those Atom from Osmosis then to Juno, that's a different identifier, a different channel. Atom has no idea that that channel exists. It only knows the channels that it's connected to. And so it's, think of it kind of like a hub and spoke, right? So you get the hub, and then there's all these spokes that go out. And that's the only thing they know about. They don't know about anything else beyond that.
Yes, that's correct. And the channel thing is intentional. So I think there's a lot of people complaining about the UX. The UX can be improved. The security UX forms the basis for why they went down this design path in the first place. Because the thinking is that right now, every single connection in the Cosmos is like roughly the same. They use like, Tendermint-like client consensus. The channels are to a specific chain. You have a certain level of security. When you have these modular security primitives that are being built in various ecosystems, and you see a lot of interop solutions trending towards modular security, you get a situation where potentially the security of a channel is not one-to-one anymore. So even if you're connected to the same chain, you could have different types of connections for that chain. And now like the non-fungibility aspect of the token becomes a feature. Versus like a bug, because if one of these connections is attacked, you maybe don't want to expose the risk of that particular state bridge to these other tokens that are minted on a more secure channel.
Right. So this is the issue that we've talked about here on the show before, which is this fungibility aspect. If you let's come back to this example of the Cosmos Hub to Osmosis to Juno. Now, if you were to move those atoms from Juno back to Cosmos, those are not native atoms anymore. Those are now Juno atoms that you've piped through Osmosis that are arriving on your on the Cosmos zone. If you want to get native atoms again, you've got to wind those transactions back in order to get your native atom again. And this is this is one of the so Strangelove is working on a module, I believe, with Noble team in order to always just be one step away, essentially, from the chain, the original chain of departure, such that we don't run into this issue. How big of an issue is this, though? I mean, how often do tokens end up like on another chain, like on a chain where they're not fungible with the original token?
My understanding is this happens quite often, since like if I'm a regular user and I don't like I'm not an infrastructure developer, I'm thinking that like if I have some token, like let's say I have some Atom, if regardless of like where I transferred from, if I'm transferring to a specific chain, regardless of the denomination path that I'm on, even if I've traversed already like 4 different chains and these are different paths, I'm expecting the same token. So like my understanding is that most users, just logically speaking, they're like, I have this Atom token. If I transfer to Juno, it should be fungible with all the other Atom that I've transferred to Juno. Why isn't it fungible? I think that's the question that you're posing.
Yeah. Okay, so once those tokens arrive on the destination chain, so I think this was an important thing that I learned here is that they're not burned on the originating chain. They're escrowed, so they're locked.
Yes.
And then what you end up with on the destination chain is a wrapped, essentially what is a wrapped asset that represents the tokens that are escrowed on the destination chain. And so there's an agreement between these chains that, well, Cosmos validators are not going to relinquish those tokens again, like on the Cosmos chain, and then we would end up sort of like with two piles of tokens on two different chains. Is there a mechanism that prevents that prevents a rogue validator or maybe like a rogue validator set on the originating chain to unescrow those tokens?
Yeah, I mean, if the chain gets taken over, if there's an economic attack on a chain somewhere in the middle of the path, the security of the token becomes a minimum of the security of one of the networks in that path, which is why the non-fungibility thing was a design choice. Because like if you have a token that was like transferred over, let's say like 5 different chains, the minimum of the security across that path versus a direct connection is very different.
Okay, yeah, we'll get into that a little bit more later, I think, when we're talking about security. So what kind of considerations? So in the context of two Cosmos chains, I think it's pretty clear how that works, and I think a lot of people are familiar with that. And it works because Cosmos chains are able to verify, they have light clients that are able to verify the state of each other, and also because they have the same consensus mechanism. What considerations must one take into account when implementing IBC outside of Cosmos? So with any other chain that's not a Cosmos SDK, Comet BFT chain, what considerations must be made in order to, well, A, determine whether or not IBC will work out of the box, and B, potentially implementing IBC in like some other way?
So there's a few layers to the IBC protocol. You have the application layer, which we went over one example just now with ICS-20 or token transfer. You have the transport layer, which is the IBC core specifications. There's like the concept of a connection, which is a conversation between two chains, channel, which is a conversation between two smart contracts or modules. And then there's a concept of a packet, which is just some data that you want to send. And then there's a concept of the state layer, or how state is bridged. And I think when most people like talk about bridges, that's all they think about. They just think about like, how is state from one chain bridged to another? So like when someone refers to a canonical bridge or like a roll-up bridge, that bridge is bridging state. Like how the packets are encoded, what the messaging semantics are, that's a transport layer concern. Most of these bridges actually don't really have a flushed out transport layer standard. So you have to implement all these three things, these three layers on the chain that you're integrating with.
Okay, got it. And so specifically when it comes to the state layer, because I think the state layer is where we run into the most complexity when it comes to having IBC be compatible across chains that are outside of the Cosmos ecosystem. What is it about different state layers, i.e. consensus engines, that make it difficult to, for example, implement IBC between Osmosis and mainnet Ethereum?
I actually have a different opinion. My opinion kind of goes against the grain here. It's I think that the transport layer is actually what's annoying to implement, since at the state layer you can, with like a modular security model, you can make certain trade-offs. Like let's say verifying consensus is too expensive. Well, why don't we like shove a relayer in a TE, and like now you can have a connection. It's not at the same level of the security. You're making some trade-offs here, but you can get connectivity. You can bring state from a chain to another chain, or using some sort of like guardian set or something. The transport layer is tricky because when you want to integrate it natively, you're essentially exposing the internal implementation details of that particular chain with the rest of the network. And I think that's not the right model to go down. And what I mean by that is the transport standard is a specification around how do you make sense of the state that you just bridged. So you bridge some state, some like state root, or on the transport side, I call it like a transport root. You bridge some like commitment. How do you make sense of the commitment? Like what are all the smart contracts talking to each other? What about the type of connection used? Can you describe that as well? And then also the data being sent over these two chains as well. The issue is that I think we need to kind of separate the interoperability stack away from the stack of a particular chain itself. So my long-term opinion is that I don't think IBC should exist as SDK modules. So right now, even in the Cosmos stack, it exists above Tendermint. So like there's Tendermint, there's Cosmos SDK, there's ABCI. At the SDK layer, IBC is a module. And I think it needs to kind of move from being a module to being a first-class infrastructure primitive, where IBC sits next to Tendermint. Tendermint goes over ABCI to some SDK, and then IBC should go over virtual IBC or some sort of interface where it can talk to an SDK that's integrating it, or a chain that's integrating it, whatever that may be. And these two things should be two distinctive primitives.
Okay, so in the case of like the transfer between, say, Cosmos and the Cosmos Hub and the Ethereum mainnet chain, the issue is making sense of the state that it's receiving. So a Cosmos Hub validator, unless it's verifying the entire state of Ethereum through some state verification, like a light client or something like that, it wouldn't be able to know exactly what it's receiving, and also whether it's been settled, right? Like whether it's finalized.
Mm-hmm.
Can you elaborate on that a little bit?
Yeah. So if we're going back to, I guess, the state layer. So if we want to bring state from Ethereum over to the Cosmos, there's obviously many ways you can do this. But if you want to verify Ethereum consensus, you run into the issue of Ethereum does not have single slot finality, as you mentioned. You have to wait 2 justifications of an Ethereum block before it's considered economically final. The finalization is an overlay on top of the block production algorithm. There's an intentional trade-off that they made for liveness and also safety. Yeah. On the client side, at Polymer, we have this internal innovation. So we have the concept of a native light client. So the native light client represents Ethereum consensus. It tracks all the state forks of Ethereum. So it'll track the finalized branch, which is the doubly justified branch. But also beneath the finalization period, it'll track all the existing forks that are happening. And what we overlay on top, what we present to the rest of the Cosmos network is you can create a virtual light client, which is also like an IBC compatible light client. It has single slot finality in quotations, meaning that it is implementing a fork choice rule over Ethereum consensus, over the native light client. So this overlay makes sense of a chain that doesn't have single slot finality. If you want only finalized block, you would create a virtual light client over a doubly justified fork choice rule, which is the economically final Ethereum view. If you want lower latency, you can trade off between security and latency here. You can say, well, I only want to wait 8 blocks. Well, at 8 blocks, you may get reorged out, but we can apply a fork choice rule and choose a fork for you. Right now we're using aggregated view because it's hard to kind of determine a canonical fork here. But essentially you're able to establish like different views into Ethereum state at different levels of security. So now you can have, let's say, multiple different connections from Ethereum to some other Cosmos chain. And each of these connections can be built with a different security model.
Okay, interesting. Well, let's talk about Polymer. I want to get into Polymer a little bit and understanding like where it sits in the stack. So we all know, I guess we all kind of understand like what modular blockchains are. What is modular IBC? Because this is something that I've seen like Polymer talking a lot about is modular IBC. How do we, so like, what's the mental model that we should be using to think about this concept?
The main mental model is, I think people previously had the misconception that IBC is bound to only using consensus-based light clients, and like had a very strict mental model for how the IBC stack was built and works. But IBC is a lot more flexible than that. IBC can work for modular blockchain. So modular IBC is kind of describing how IBC can work for modular blockchains. And a lot of this is really happening at the client or state layer of the problem. Because the transport layer should be standardized. And then at the state layer, you're connecting to, let's say, a rollup on Celestia. So this rollup on Celestia relies on Celestia for data availability. It can, let's say it's an optimistic rollup. Maybe it's sovereign. Let's say it's sovereign. So there's no like canonical settlement layer. It can settle anywhere. In fact, like all the bridges to it are technically like how it settles. So all of its bridges outbound over IBC are kind of like the canonical view of that rollup. And then this is usually enforced with some sort of social consensus. So on the IBC side, you can say, I can have a client for Celestia. So Celestia has a consensus network. This network kind of attests to data being available on the Celestia data availability network. You can have a client for that saying that it will present all of the blocks that are made available on the Celestia network. And then you can establish perhaps an optimistic IBC connection to one of these rollups, or these sovereign rollups, be it that they're optimistic. And then in this optimistic connection, the way it would work is you do the handshake, you post a new block from this optimistic rollup over this IBC connection to an app chain. The optimistic client will then check. It has a dependency on the Celestia client. It'll ask the Celestia client, hey, have you seen this block? Is this data actually available? If this data is available, then you would start the fraud window, because now you know that the data was made available on the Celestia network. Anyone would be able to read that data, generate a fraud proof. Therefore, I can start the fraud window. And then after some fraud period, that you would like settle or finalize that block.
Okay, let's talk about this. You said something here that I think is really interesting, and I think will help understand where Polymer sits in the stack. So you said that the transport layer should be standardized, and we said earlier that the transport layer is where we run into we run into issues when working across different types of consensus engines. What does that mean exactly when you say the transport layer should be standardized? And is this where Polymer sits? So like if we have application layer, transport, and state, Polymer sits at this kind of transport state layer level, correct?
Yes. So the main issue that Polymer is trying to solve is bringing the IBC transport standard to different chains. So the way we mental modeled it is very similar to, I guess, like what I was talking about before, where like you want to separate the idea of the state that you're committing to on the chain itself. So this is execution state. And you want to separate that from transport state, which is all the communications in and out of the blockchain. Like my argument is that these two things should be separate things. Like previously, I would say like all chains have some sort of execution. They have some like, data store, some like data that they've committed to, and they have a single state root for all of that. I'm arguing that you need a state root. You also need a transport root. So Polymer's main job is to commit to this transport root on behalf of all the chains that it's connecting to. And the advantages of this is if you can standardize on the commitment format for this root and also use the same data structures for this as well, then the rest of the network only needs to implement the same proof checking logic, meaning that to integrate a new chain, it's like either you just integrate Polymer directly, or you have this library, or you integrate IBC as a library, but use it as a completely separate thing, have it run kind of separate to the chain process or the chain logic, and be able to leverage existing infrastructure so you don't need to build a new relayer. You don't need to implement your proof checking logic and have every single chain in the rest of the network adopt it. now everyone's kind of agreeing on the same language. So it's like now everyone speaks IBC or speaks English, and they can all communicate. And then, but like how that data is forwarded from chain to chain, that's the consensus problem that you were mentioning. Like if you want to verify consensus of a chain on another.
So the transport standard, when you say the IBC transport standard, is this a standard that exists in the IBC spec, or is this a standard that you guys are proposing?
This exists. So this is the IBC core specification. So this is IBC connections, channels, and packets.
Okay. And what does Polymer then make relayers somewhat obsolete because all the transactions are just going through Polymer's transport layer?
No, I would say Polymer IBC enables a chain, meaning that if Polymer is running or like integrated with a chain, on the relayer side, this chain now becomes visible to the rest of the IBC network as any other Cosmos chain. So I would say Polymer makes a chain look like any other like IBC enabled app chain.
Okay, whether it's a Cosmos chain or any other chain.
Yes, that's correct.
Okay, cool. When interacting with chains, I guess, like, maybe this comes back to what I mentioned at the top of the show, which is that you think that most interoperability solutions are not standards, but they're actually products. When comparing Polymer to something like Axolar, Axolar essentially acts as a massive, sort of like a massive multi-sig, right? With a set of validators. Now you can agree, you can make that security trade-off, or and I think most people do, and like it's fine. But how does Polymer differ from that fundamentally?
The difference isn't in the security model, in my opinion, because I think long term, every single interoperability solution will converge to the same set of security models that have trade-offs in between them. Since like with light client-based security, it's going to be somewhat more costly than perhaps just using like a centralized relayer like layer 0, getting more on the centralized side of the security spectrum. I think the difference is when you're building this interoperability solution, how are you thinking about the problem? So I think for a lot of interoperability solutions, the way they thought about the problem is, how can I like do token transfer? How can I solve for this feature, this feature, that feature? And a lot of the features they're solving for are application features. Like, how do I send some messages or send some bytes? And as they go down this laundry list of answering all these questions, they would be going down the same design path as the folks like Chris goes, and a lot of the folks at the ICF have gone through with IBC. Because if you want to design a protocol that, as I mentioned earlier in the call, that can do like version negotiation, handle like channel upgradability, authenticate communication, there's like a long list of features that as you design your protocol, you get to this like standard specification. So I'm saying that a lot of these interoperability products are very early in their journey. They've just answered like a few product-facing questions with what they've built, and then right now they kind of need a longer-term like reconcile that. So it's possible that they can convert what they've built as a product into a protocol, but that's a very difficult path to take. And the path that we took is we start with the protocol, which is like the transfer layer protocol specifically, and try to work off of how do we extend this protocol to other chains, where this protocol has a lot of collaboration, it has a lot of builders, it has a lot of network effects.
Okay, I see what you're saying. So from your perspective, it's like a bottom-up approach, whereas a lot of other interoperability solutions are having a more top-down approach, perhaps addressing some issues that applications are facing by making some trade-offs on, well, probably, one, the security model, but also the the long-term viability of the solution as the ecosystem converges towards standards. And
Yes,
by
that's correct.
having a bottom-up approach that implements standards first, I mean, you have to make a bet on those standards, of course,
Yeah,
and
yeah, we are making a
that the
bet on
standards will be winning. And I think like, you know, we agree on the standards part. That the long term implications are that the standards will win out, and that the applications will benefit from having all the functionality of the standard.
Yes, that's correct. I think from the product point of view is, if you imagine the instate of the world being every chain has native IBC interoperability. If every chain implements IBC natively, a lot of these products don't really have a place in this world. They've gone off and implemented some custom solution, you know, be it like, I guess in Axolar's case, they have cross-chain gateway protocol. They have a lot of things that they built, a lot of features that they've built off of zero standards. They do support IBC because they are a native Cosmos chain on the Cosmos side, but they're not trying to extend IBC as a standard to these other chains. So when these other chains do have IBC implemented, they're just going to be using IBC directly. Then Axolar no longer has its like monopoly holding on because like right now the way it's designed is, if you integrate CGP on one end, you're not able to switch between that and IBC. With IBC, any chain can be a middle hop. And then you kind of like lose a monopoly. So it's kind of like a lot of chains are disincentivized to even try to make IBC a broad standard, because they kind of like, it weakens their position. So like the perspective that we've been thinking about it is, we want to imagine a world where you do have this like neutral infra layer on the interoperability side being IBC. And then with this neutral infra layer, who can build the best infrastructure? Since now, like, because chains can switch easily between providers. So like I can easily switch my channel between one connection versus another. This would be between two different middle hops. Who can build the best IBC middle hop? And that's the question that we've been trying to answer with Polymer.
Are there any useful analogies to standards development in web technologies or the OSI model? Like I'm trying to think if there's any interesting analogies that we can draw from other standards, like, I don't know, SMTP, for example, right? Which is like the mail standard, and how there's been applications that are built on top of that, or kind of, you know, different server implementations of SMTP. Are there any useful analogies here?
I mean, I still think the TCP/IP analogy is good, because there's a clear distinction of where it sits relative to application protocols. Earlier in the call, I mentioned, you know, some folks have taken the view of IBC is too complicated. Why don't we just do like a get posting, or perhaps just a send bytes thing? I would argue that those are application protocols. Like those are very simple. You can build that on top of IBC transport, but that's not the only thing that you can build. So you can have HTTP on top of TCP/IP, but you can have gRPC. You can have like a multitude of different application protocols that can be built on top. And it's not just application-specific protocols for like token transfer. There's infrastructure protocols that you can build as well. So like the IBC transport layer exposes enough information for you to build decentralized relay incentivization in the form of ICS-29. And I think that's just kind of scratching the surface here.
Okay, and is the idea for Polymer to become a platform where developers can build applications that leverage the standards, or does Polymer remain this somewhat agnostic platform, and applications are built on the edges? Like, what is the amount of products that you anticipate Polymer to host?
I don't see Polymer as like hosting these applications uniquely or specifically. I see it more as a like infrastructure primitive. So I see it as a neutral infrastructure primitive that extends, or like IBC enables certain chains, and also like acts as a very efficient IBC middle hop to our longer term vision. And the reason why we even want to bring the IBC transport standard to these other chains is because there is a lot of innovation on top of the IBC transport already. And a lot of these innovations, like ICS-29, can only be built on at least currently, it can only be built on the IBC transport standard. And with the innovation at the app layer of IBC, we want to extend those innovations to other chains. So just by IBC enabling or bringing the IBC transport to a particular chain, you also get all of the IBC application standards that have been created as well. So as like there becomes like a network effect here of like the more innovation on the app side drives more adoption on the transport side, and so on.
Cool. Let's talk about the let's talk about ZK IBC, optimistic IBC, and then later on we can talk about ZK Mint. So what is ZK IBC and optimistic IBC, and how is it used?
So at least for the time being, both terms are referring to the type of underlying IBC connection. So in order to like bridge state is what the connection is responsible for. Bridge state from chain A to chain B. You can do it using ZK Light client or ZK IBC connection, or you can use an optimistic client or a optimistic IBC connection. So it's just referring to how the state is bridged for now.
And so in the case of ZK IBC, would that be used when bridging tokens over to Ethereum or sending messages to Ethereum, or how does that work compared to maybe that example we gave earlier when interacting with a non-EVM chain, or sorry, an EVM chain that would implement, say, a ZK IBC implementation? How would that transfer work?
Yeah, so for us, we wanted to have a default but sane security model for going to Ethereum. So we wanted to rely on consensus-based security. So we wanted to have some way to prove the consensus of our chain on Ethereum. And there's multiple ways to do that. We looked into doing it naively, which was too expensive. We looked into generating essentially a ZK proof, zero-knowledge proof of consensus of a Polymer on a particular chain. We realized that generating the proof would become too expensive. So we went down this path of building ZK Mint, which we'll talk about soon. But the idea of ZK Mint was we want to both be able to prove consensus, but also be able to do it efficiently within a reasonable time period. You don't want to wait like 30 minutes to generate a proof. You want to only wait like a few seconds.
So the idea is for ZK Mint. So ZK Mint is like a Tendermint light client that can run as can it run as an Ethereum contract? Is that the idea?
The verifier for ZK Mint proofs can run as Ethereum contract.
Right.
ZK Mint itself is a Tendermint or a Comet BFT fork.
Okay. So if like Ethereum validators could run ZK Mint, they would be able to verify the proof, verify the state of a Cosmos chain, and then using the verifier that's sort of a smart contract on Ethereum, they would be able to verify that state on chain.
Yes, that's correct. Yes.
Okay.
Sorry, go ahead.
No, go on.
I was just going to say that we'll talk about how optimistic plays into this as well, how like the two interplay together very nicely. But on the ZK Mint side, it is, so like we have some marketing out. It is like a ZK friendly Tendermint consensus. But I would say that it's a little bit more than that. From my perspective, we kind of see like the high level idea is that if you want to bridge or sit between different ecosystems, right now, bridging the Cosmos is like fairly simple because every chain is more or less the same. It's very homogeneous in terms of the architecture. But when you're going across ecosystems, all the architecture becomes heterogeneous. So in order for something that sits in the middle to be efficient, you need to be adaptive. So I, as a middle hop, need to be able to adapt perhaps the header format that I'm generating. I'm not committing to different data. This is just how the data is structured. That data needs to be structured in a way that's like easy to verify or easy to be verified on a particular execution environment. So the ZK Mint's actual innovation is being able to derive multiple versions of a header. So the same data, but multiple versions securely, and allow for us to be able to be adaptive to all these different execution targets, regardless of whatever we're connecting to. Like establish the most efficient connection possible with a high level of security.
Okay, so if the way I understand that, so we may have like header formats on Cosmos and header formats on EVM chains that are different. What Polymer would do in this, which Polymer Access here is sort of the it has its own header format that it will interpret any sort of header format that will get interpreted then by destination chains that are compatible, or sort of like it'll convert them back into whatever the destination chain needs as a header format. So it's kind of like a translation layer also that sits between these different chains.
Yes, that's correct. Yeah. So
okay, got it.
We're able to kind of be backwards compatible with all existing Cosmos chains while being forwards compatible or be able to create efficient connections on any number of new chains as well.
Okay, interesting. And so for this to work, I mean, you guys are deploying obviously ZK verifiers on all of the kind of EVM chains, so that EVM chains can efficiently verify Tendermint consensus using this ZK Mint. What about other chains? So what about, say Solana, or I guess Near is an EVM chain, but like the Move ecosystem or other VMs and consensus mechanisms that are not Cosmos and EVM?
It works just the same. So the verification logic is like you could implement the verification logic anywhere. So currently the types of proofs that we use is Groth16. Without diving into too many details, on the mathematical side, you're essentially performing a few pairing checks to verify a proof. So like in the smart contract, you would have to define all of the pairing check logic, which is just some mathematical functions, and you would do this check about like 3 times. So this would be able to like verify that proof. So it's something that you can implement anywhere. Yeah.
Okay, and so the ZK Mint is useful in the context of Ethereum. Is the ZK optimistic IBC then more useful in the context of, say, Celestia or optimistic settlement solutions?
Well, it's definitely useful in the context of an optimistic rollup, because you need to like there's no other way to kind of speak directly to an optimistic rollup, since the connection, the nature of the rollup is optimistic. The nice property that we found going to Ethereum was that if we only use ZK proofs, so like we figured out how to reduce the gas cost of the verification of Tendermint consensus down to something reasonable-ish, on the order of over 300,000 gas still, though. We found that if you wanted to like do this verification at some reasonable latency, let's say like 10-second, 30-second latency, you're going to incur significant operating costs on the order of perhaps $10 million to over $100 million if the network is highly active. And this is just not practical. And most folks, like even with some incentives in place like ICS 29, it's possible that you have to wait forever for enough incentives to accrue to pay a $40 cost to do this client update. Client updates in the Cosmos are insanely cheap, like in most cases, on the order of cents. But this client update is going to be like $40, $100 maybe even. So we're like thinking about how do we, balance the cost aspect without trading off on the security side. We're like, okay, if you add an optimistic verification, you get nice properties from both. So with an optimistic verification approach, you essentially set a max bound on the latency that you have to wait. So let's say there's not much economic activity going on, you can post a new update, so to update the state of the client, and you can wait some period of time. Let's say like 30 minutes to an hour. And after that period of time, it's now that connection is settled and you're able to transact. Within the fraud window, you can use the ZK proof both as a fault proof to prove that fraud was committed. Some relayers posted an invalid client update. You can prove that. You can also use it as a validity proof. So it has a dual use case, meaning that if I want to speed up this process, so I don't want to wait the whole fraud window. Someone has like a really big transfer. They want to transfer like, I don't know, $10 million. And they're like, oh, $40, I'm willing to pay that. I'll give out $40 in incentives. And now everyone's transactions can go through. Like we use a ZK proof. We prove consensus right away. Everybody's transactions can go through.
So can you talk a little bit about your collaboration with Celestia and how you facilitate transactions to Celestia rollups? I guess specifically, I'm curious about, there are many different settlement sort of like roll-up solutions on Celestia, so like Dimension and rollups, etc. How does Polymer then interact with all of those? Are there different implementations for each of these solutions, or can you interact just with the data availability there at Celestia? Like at which layer of the stack is Polymer interacting with?
Polymer can serve as a middle hop between like rollups in the Celestia ecosystem and app chains. It can serve as kind of like a pseudo like soft confirmation layer, so to speak, meaning that if you have a bunch of optimistic rollups, you can technically have those optimistic rollups connect to Polymer first, and Polymer can kind of like, I guess, like verify. For some rollups, it makes sense. It's like you can kind of do the verification. So if you do the execution right away, you can say that, is this right or wrong? I can soft attest to this, and this is a different security model. You kind of have to account for this. So Polymer can do that. But I would say that some of our ongoing work with a number of these rollups is to get IBC natively implemented into those particular rollups. They can also opt to connect directly. So the nice thing about IBC is you're not forced to use a particular settlement layer. So like if you think about the settlement layer as like, did I finalize all of my transactions that it is like canonical view. For sovereign rollups, there's no like canonical settlement layer, so they kind of settle on all their bridges. With IBC, you can basically use anyone. You can connect directly to them if you want to run this optimistic client, but maybe not everyone wants to run the optimistic client. Polymer can do that on their behalf. So it's kind of like, it makes the UX easier for chains that don't necessarily want to run the optimistic verifier for every single like rollup, because like every single rollup, the optimistic fraud proofs for that rollup may require the app chain to run WASM, like a WASM like fraud proof like verifier. Maybe it's MIPS based. Maybe it's maybe you have to run the whole app chain. So like I believe that there's like some chains that you have to generate a whole I guess like IBC app, Cosmos app for that chain, and re-execute all those transactions to identify the faulty transaction if they don't have like a more granular fraud-proof mechanism. So it's a lot of overhead for every chain to do that.
Okay, interesting. I'd like to maybe like talk a little bit about the network topology of IBC chains, and like currently as IBC exists in Cosmos, we talked about this a little bit earlier, is we have a very hub and spoke like model where a chain has to have transport layers, or essentially relays, with all other chains that it wants to send tokens to, and you have to multiply this times X number of chains. Now there is some routing that can happen, or I believe that's not yet fully implemented, right? Like the routing between chains that would allow you to move tokens from like chain A to chain Z, right? And like it'll just go through whatever chains that it can find a passageway. Like this doesn't feel very efficient, right? Currently in its implementation. What is the ideal network topology for IBC for that to be as efficient as possible? And does Polymer have a role to play in creating more efficiency between all the IBC chains, as acting as kind of a middle hop between any IBC transfer, whether it's happening within Cosmos or outside of Cosmos, or
I would say that the most efficient network topology is probably going to be multi-hub and spoke. So if I think about like the internet, you have like a lot of nodes talking to like a local router, which then like forwards those packets onwards. So this is kind of already, you can already kind of visualize this like multi-hub and spoke model. Our work on multi-hop IBC is going to help somewhat alleviate the needing to transfer across like a bunch of different chains if there's not a direct path between one chain and the destination that you want to transfer to. With multi-hop, you can establish a channel directly over existing connections between chain A and chain Z. This improves the UX a little bit. You can further improve this by allowing people to perhaps like upgrade between different paths and also specify multiple paths potentially as well. Because then now the liveness of the path is better. Obviously, there's some security considerations here to be made, but you can essentially have like multiple paths like leading or backing a particular channel. So the channel liveness can be a little bit better as well. Polymer's role, in my opinion, is based on the question that I posed earlier in the podcast around, in a world where every chain has IBC natively on that particular chain, what does the most efficient middle hop look like? And our perspective is that a very efficient middle hop is going to be a master at adaptation. We're going to be, because if you're connecting different like heterogeneous ecosystems, the middle hop has to be very adaptive. And we kind of already see it with modular blockchains. If you establish a new modular blockchain, let's say it's an optimistic rollup, then as I mentioned earlier, you have to kind of expose the verification details of that execution to every other chain in the IBC network, unless there's a hub that you can connect to that abstracts away those implementation details. I believe that's how Dimensions Hub works with its rollups. I think that if you just talk to Dimensions Hub, that you think you're talking to like one of its rollups. At least that's my naive understanding from their docs.
Okay, and when considering the fact that Polymer sits as a middle hop, and if Polymer is successful, it could sit as a middle hop between lots of different chains and potentially have like lots of liquidity going through it. Is it ideal for Polymer to have this important of a role as kind of sort of central hop, where if Polymer goes down or if something happens to that transport layer, that essentially the rest of the chains that are dependent on it would not be able to send transactions anymore? So it's like, we started off right, like IBC is great because it's a decentralized network of chains, and we'll always find like some sort of some sort of a route to be able to send assets from one chain to another. It doesn't depend on any central hub. And now we're sort of like, exploring this idea of having an IBC hub. What do you think is the right balance there? And like, how do we deal with those trade-offs?
Yeah, so our long-term vision is going to be on the order of trust minimization. We identify that there is some issues with having a single hub between all these different chains. Ideally, chains shouldn't need to rely on having needing a middle hop per se. Our long-term plans for ZK IBC is we want to implement all the IBC transport logic in ZK circuits. So what this means is that even if Polymer is never online, you'll be able to generate at a very high level, you'll be able to generate a ZK proof of this of the underlying connectivity between chain A and chain Z through Polymer. So if Polymer is sitting in the middle of these two chains, it will be as if like Polymer didn't like technically exist as a chain. It's a provable channel path between these two chains now, if that makes sense.
Okay, yeah, no, I understand. So without even with Polymer not being there, because these chains would be using Polymer's transport layer, they would still be able to talk to each other directly without Polymer facilitating the transfer.
Yes, that's the long-term plan, but I think there's like certain caveats to this requiring that. I think there'll be a hybrid approach. I think some chains will need, like if it's optimistic rollup, like you need to optimistically verify the rollup. You need like this fob when it appears. So there's like some mechanisms on a chain-to-chain basis. Maybe they can rely on full ZK. So maybe like the channel path between two chains can be full ZK. Maybe it can't. Maybe it needs that middle hop. I think it's going to be somewhat of a hybrid model in the future.
So what's the roadmap, and talk a little bit about some of the teams that are building on Polymer, and who do you expect to be integrating Polymer when Polymer hits mainnet?
Yeah, so we expect to obviously integrate all of the existing teams building in the Cosmos and that are IBC enabled. But what we're really trying to target in like soon after launch, so initially we're just going to establish connectivity to Ethereum, or IBC connectivity to Ethereum. We really want to push IBC as the interoperability story for rollups, since I imagine that in the future, a lot of activity is going to move from ETH L1 to the various rollups building on top of them. And there will be a lot of rollups in the Cosmos ecosystem, in the Celestia ecosystem, and so on. And I think that the IBC, or the interoperability story for rollups, is still like yet to be established. And like IBC is a critical component of that. Like we need to get IBC in the OP stack. We need to get IBC in like the Ethereum ecosystem, and the way we do it natively is through its mini rollups. Because I think getting IBC natively into Ethereum L1 is kind of is probably not going to happen anytime soon. But on the rollup side, it's much more possible.
Cool. What's the roadmap for mainnet?
Yeah, so our rollup for mainnet is we're going to establish connectivity to Ethereum first, and then we're going to target connectivity to various rollup networks on Ethereum as well, in addition to kind of rollups in the Cosmos side.
Sorry, I mean, like, what's the timeline?
Oh, the timeline. Oh, sorry. We're shooting for early next year. We're currently in a private testnet, but we're thinking to launch the public testnet later this year, and then followed by a mainnet early next year.
Okay, cool. And like, can people already start leveraging like early primitives that Polymer are building to start integrating with, say, the rollups or their app chain?
Yeah, so we're planning on releasing some docs around IBC SDK. And with IBC SDK, you'll both be able to interact with existing Cosmos chains as well as Polymer, and build on IBC transport on smart contracts on Ethereum, and be able to interact between Ethereum and Cosmos chains and so on.
All right, cool. Well, thanks a lot for coming on. This was really interesting. I've learned a ton about IBC and how it works, and I hope people who are listening also learned more about IBC. And yeah, really looking forward to seeing Polymer go live and creating more interoperability between Cosmos and the rest of the blockchain ecosystem. So thanks, Bo.
Thanks, Ed.